નમસ્કાર, હું આદર્શ છું. વેલકમ ટુ આદર્શ એજ્યુકેશન સોસાયટી. Today in standard 10th subject mathematics we are going to learn chapter 13 surface area and volume. Today in example number 14, here you can see there is an open bucket. It is an open bucket is in the shape of the frustum of a cone mounted on a hollow cylinder. Here it is made up of metallic sheet. The diameters of the ends of the bucket are 45 centimeter and 25 centimeter. So the radius of the top is 22.5 centimeter and the radius of the base is 12.5 centimeter. And the vertical height of the bucket is 40 centimeter. And that of the cylindrical base height is 6 centimeter. The cylindrical base is 6 centimeter high. So radius of the cylindrical base is same as the radius of the base of the frustum of the cone. Then find the metallic sheet used here for making this bucket, and then we have to find volume of the bucket, volume of water the bucket can hold. So we have to find the metallic sheet used for bucket. At the same time we have to find volume also. So let us go for first of all metallic sheet used. For metallic sheet we have to calculate the curved surface area of the cylindrical base, curved surface area of the circular base, and curved surface area of the frustum of the cone. So for curved surface area we have to find the slant height of the cone, and therefore the slant height of the frustum of the cone is here square root of h square plus r1 minus r2 whole square. So square root of, here the height of the frustum of the cone is here 30, we say capital H, and that is 34 centimeter, 34 square, plus r1 is 22.5 minus 12.5 and whole square. So here that is equal to, therefore the slant height is equal to here 34 square, and square root of 34 is here 1156 plus 22.5 minus 12.5, and that is 10, and so the 10 square is 100. So here that is equal to square root of 1256, and when we find the square root, here we will get in decimals 35.44 centimeter is the slant height of the frustum of the cone. So now we can calculate metallic sheet used. Therefore the area of metallic sheet used to make this bucket is equal to curved surface area of the frustum of the cone plus here area of the circular base, area of circular base plus area of this cylinder, area of curved surface area of cylindrical base. So we can write the formula here. The formula for the curved surface area is pi RL, pi RL. So here radius is R1 plus R2 multiplied by L, plus here area is area of the circular base pi R square, plus this area is 2 pi R H. So here we can take pi common, and thus we will get taking pi common, and so we will substitute the value R1 plus R2 multiplied by slant height plus R square plus 2 R H. So now substituting this value, we get 22 by 7 in bracket. First of all, R1 plus R2. So this is R1 plus R2. So directly 22.5 plus 12.5, that is 34 and 35. Directly I am writing here it is 35 multiplied by slant height. Slant height we have calculated 35.44 plus R square. So here the radius R square. Here we say this is R1, base is R1, and here also it is R1. So here there is radius R1. So we can take R1 square. Here also R1. So what is the here radius R1 is? Here it is 12.5. So 12.5 square plus 2 times 12.5 multiplied by height is 35.44. So bracket over. So now we can simplify here. Here you can see now it is 22 by 7 multiplied by, in bracket, first of all 35 into 35.4, 35 into 35.4, that is R1 plus R2 multiplied by slant height. And so when we multiply, it is 1240.4 plus here 12.5 square, that is R1 square. So square of this is 156.25 and plus here 2 times here 12.5 multiplied by 35.5. So 2 times 12.5 multiplied by 35.5, that is 2 times R1 into H, and that is equal to here 100 and that is we say here it becomes 12.5. This is height of the cylinder we have to take. So H, and that is equal to 6. So here it is 6. Height is 6. So 2 into 12.5 into 6, and that is we say here 150. So this is 150. So now 22 by 7 multiplied by the sum of this. Here 100. This is this plus this, and on adding this we will get here up to 2 decimal places we will get here, and that is 1546. 1546.65. So we can also say here 2 decimal places, so divided by 100, and we can cut the common ones. Now here you can see when we cut the common ones, here first of all we can cut 7 ja. Okay, so if we cut 7 ja, here 7 2s are 14, 7 2s are 14, 7 0 ja, 7 9 ja, and 5 ja. So here we get 22 multiplied by 22,095 divided by 100. So we can cut again here 50, here 11 ja. Now here it is 10 ja. So we can cut 5, and that is 4,419. So now 4,419 multiplied by 22 multiplied by 11, then divided by 10, that is up to 1 decimal place, and that is equal to, here we will get 4,860.9, 1 decimal place, so 0.9 centimeter square is the area of the metallic sheet used for making this bucket frustum of a cone. It is in the shape of the frustum of the cone with cylindrical base. Now our question is to find volume. Also it is asked how much volume of water it can hold. So here the volume of water the bucket can hold. Now volume of water the bucket can hold. Volume of water the bucket can hold is equal to, here the volume of frustum of the cone. So volume of the frustum of the cone here is formula is 1 by 3 pi r square h. So here pi h in bracket r1 square plus R2 square plus R1 multiplied by R2. So this is the formula to find the volume of the frustum of the cone. Now substituting the value 1 by 3 multiplied by 22 by 7 multiplied by height of the here frustum of the cone, that is bucket, that is 34 centimeter, multiplied by here now in bracket R1 square. So R1 is equal to here it is 22.5 square, 22.5 square plus 12.5 square plus it is 22.5 multiplied by 12.5. So bracket over. Now we can simplify 22 by 7 multiplied by 34 multiplied by here 22.5 square. So the square of this 506.25. Then square of 12.5 is 156.25, and then product of this, and that is 281.25. So on adding this here 1 by 3 multiplied by 22 by 7 multiplied by 34 multiplied by the sum of all this, and that is 943.75. So now we can cut the common ones. Here you can see, if we cut, there is nothing common. 3 is also not common, 7 is also not common, and so the numerator product 22 into 34 into 943.75, and that is 7059.25. In here numerator 2 decimal places as it is, denominator is 7 3s are 21, and so when we divide by 21 here, on dividing this by 21 we get 33,615 point, and here you will get in decimal. When we divide, actually we will get here 4762 and so on. So this is what, nothing but centimeter, so approximately it is centimeter cube, that is 33,615.48 centimeter cube is the volume of water this bucket can hold. But now it is in centimeter cube, so we can convert it into liter. So when we convert it into liter, it is divided by 1000. 1000 centimeter cube is equal to 1 liter, and so it is 33.61548 liter, and so it is approximately up to 2 decimal places 33.62 liter, and this is the volume of water the bucket which is in the frustum of the cone can hold this much water. In exercise 13.4, question number 1, a drinking glass is in the shape of the frustum of cone of height 14 centimeter, and the diameters of the two circular ends are given. So here the radius of the one end is 4 by 2, that is 2 centimeter, and another radius is R2, that is diameter 2 by 2, that is 1 centimeter. Then we have to find the capacity of the glass. So to find the capacity of the glass, that is we have to find the volume of the frustum of the cone. So therefore capacity of the glass which is in the shape of the frustum of cone, and so that is equal to volume of the frustum of the cone is equal to 1 by 3 pi h in bracket R1 square plus R2 square plus R1 multiplied by R2. So now substituting the value here, 1 by 3 multiplied by 22 by 7 multiplied by height is here 14 centimeter, in bracket R1 square, that is 2 square, plus R2 square, that is 1 square, plus 2 multiplied by 1, and that is equal to 1 by 3 multiplied by 22 by 7 multiplied by 14 multiplied by, in bracket 2 2s are 4 plus 1 square plus 2 1s are 2, and that is equal to, here we say 1 by 3 multiplied by 22 by 7 multiplied by 14 multiplied by 4 plus 1 5 plus 2 7. Cutting the common ones here, 7 7 cut, so 22 multiplied by 14, and that is 14 to the 28. 11 ja 308 divided by 3, and that is here 3 1 ja 3 0 3 2 ja 6, and then 2 by 3. So 102 2 by 3 centimeter cube, and that is in decimal if we convert it is 102.666 and so on centimeter cube. So approximately in decimals it is 102.67 centimeter cube. It is the volume of the frustum of the cone, and that is called the capacity of the glass which is in the shape of the frustum of cone.
Thank you for joining us.